Hey everybody. In class today we worked on solving equations when there is a variable on both sides of the equal sign. Tonight we're going to take a look at similar problems, but we're going to see what happens when we have some trickier equations, ones that involve decimals or fractions. So we're just going to take a look at 4 examples, and here is our first one. We have negative 1.3v plus 5.9 equals 2.5v plus 2.2. Now, as usual, we want to start by, if we can, eliminating a variable on both sides. And we can start there because both sides are simplified. So let's start by getting rid of this negative 1.3v. I'm going to add 1.3v to both sides. That's going to cancel out over here. I'm going to be left with 5.9 equals 3.8v plus 2.2. Now, I just have a two-step equation. Even though these are decimals, we're going to solve this the same way, using inverse operations. Plus 2.2, inverse operation is subtraction. Cancel there, 3.8v equals 3.7. And now we have to divide. Divide by 3.8. Now, I don't need to use a calculator. I also don't really want to do long division to figure out 3.7 divided by 3.8. But I can just make this into a fraction. Even though I'm dividing decimals here, I have 3.7 divided by 3.8. We can think about it as 3.7 over 3.8. But we never want to have a decimal in a fraction. Is multiply the numerator and the denominator by 10, because that will move the decimal to the right one space on each of them. So I'm going to get v equals 3.7 times 10 is 37. 3.8 times 10 is 38. And since I can't simplify that fraction, this is my answer. V equals 37 over 38. Here's another problem involving decimals. This time we have an extra step involved. We're going to have to distribute to get this problem started. So if I multiply both of these by 0.3, 0.4 times 0.3, I know 3 times 4 is 12, and I have 2 decimal places. So I'm going to have 0.12x, and I have 0.3 times 1.5, negative 1.5. If I think about it as 3 times 15, I get 45, and I have 2 decimal places. So this will be minus 0.45 equals 0.2x plus 3. Now, I want to eliminate one of my variables now that I have both sides simplified. So I'm going to get rid of this 0.12x minus 0.12x. Now, if I think about it as 0.20 minus 0.12, it's going to be 10, it's going to be 1, I get 8, that's 0 point, so this becomes negative 0.45 equals 0.08x plus 3. Now I need to subtract 3 from both sides, so I get 0.08x on the right, and this is going to be negative 3.45 over here on the left. It makes it easier because both of these are negative. We can just put them together. Now I need to divide by 0.08, use my inverse operation, and I get x equals, this is another case here where I have 2 decimals I'm dividing by each other. I'm just going to make it into a fraction again, but this time I want to move the decimal over 2 places, so I'm going to multiply both of these by 100. So this will become negative 345 over 8 as we move both of those decimals over 2 places. Now, I could do long division here, turn this into a decimal, or use a calculator, but I don't want to do either of those. I'm just going to leave my answer as a simplified fraction. Now, when we have fractions in our equations, there's a few different ways we could go about this. We could just do our inverse operations, where we subtract 1/3 x from both sides, or subtract 5/3 x from both sides. But since we have fractions and we have some different denominators in this problem, we'd have to turn everything into have a common denominator, and that could be a lot more work than it's worth. One way to solve this type of equation is actually to eliminate the denominators before we start doing anything else. And we can do that by multiplying both sides of the equation by the same number. Now I want a number that is going to be divisible by all three of the denominators. I have 3, 12, and 4, and I know that 12 is divisible by all of those. So I'm going to multiply both sides of this equation by 12. Now, when I distribute this 12 to simplify, 12 times 1/3 x, 12 times 1/3 is going to give me 4. So I have 4x plus 7/12 times 12 is just going to give me 7, right? Because 12 times 7 over 12, we make this 12 over 1. 12 divided by 12 is 1. 12 divided by 12 is 1. When we cross cancel, 1 times 7 is 7 over 1, which equals 7. Now on this other side, we have 12 times 5/3 x. You can show that over here too. 12 times 5/3, it's 12 over 1. We can cross cancel. 3 divided by 3 is 1. 12 divided by 3 is 4. And we get 20 over 1. So this becomes 20x, and we have 12 times 1/4. That's like 12 divided by 4, so that gives me -3, -3. Now we can solve this equation just like we would solve any other equation with variables on both sides. We can subtract 4x. We get 7 equals 16x minus 3. I'll add 3 to each side. Now I really should have drawn a line here first. 10 equals 16x after these cancel. And I divide by 16. Now here we have a case where 16 doesn't go into 10, but it is a fraction. I can simplify it. I can divide both of them by 2. And that gives me 5 over 8. 5 over 8 is my final answer. Alright, last one. Same type of problem here. I want to multiply both sides by something that's going to eliminate both denominators of the fractions I have. 5 and 10, I know that 10 is divisible by 5 and 10. So I'm going to multiply the left side by 10. I'm going to multiply the whole right side by 10. On the left side I have 10 times 2/5. 10 times 2 over 5. It's 10 over 1. 5 divided by 5 is 1. 10 divided by 5 is 2. You get 4 over 1. So that becomes 4m. And we have 10 times -3. That'll be -30. Now here, this is kind of a different case here, because we're not going to multiply this 10 into these parentheses here. This is considered one term because it's 1/10 times the parentheses. So we're going to multiply 10 by 1/10 here, which will give us 1 times 2m minus 4, and then 10 times -1 minus 10. Now, if we distribute that 1 over on the right side, nothing's going to change because it doesn't mean anything when we multiply by 1, so that's 2m minus 4 minus 10. Now we can combine like terms. We'll get 2m minus 14, and now we can solve. Subtract 2m, 2m minus 30 equals negative 14. We add 30 to both sides, and we get 2m equals 16. Divide by 2, and hey look, we actually get a whole number this time. M equals 8. Alright, I know that was a lot. It's definitely a lot of writing for just 4 problems, but it's good to know how to solve these types of problems when they're in their most difficult form, because if we can solve the hardest types of problems, we'll be able to solve anything. Go ahead, finish up your notes, submit it through Canvas, and I will see you all tomorrow.